everyone. My name is May. I'm a program manager working on Azure Machine Learning service. So under Azure AI, there are three major pillars. The first pillar is Azure Machine Learning service, which focus on providing the tools and service to help data science and development teams to build their own models and productionize it. The second pillar is AI apps, so products like cognitive service that offers a collection of pre-trained model that you can just use out of box. And the third pillar is knowledge mining, so product like Azure Search that helps uncover the insights of your content in the format of documents, PDF, or medias. Azure Machine Learning Service is where we are. It is designed for all skills level. We offer POUI drag and drop experience for data analysts or citizen scientists to just get started with machine learning. For professional data scientists, we have built-in Jupyter Notebook for a code-first experience. We have industry-leading ML ops that aims to bring the DevOps standard into machine learning to help streamline your machine learning lifecycle from building a model to deployment and to management. Azure Machine Learning Service love open source. We have built-in support for popular framework like PyTorch, TensorFlow, Scikit-learn. And lastly, we aim to build a trusted platform by offering enterprise-grade security through role-based access control and virtual network support. The topic for this session is how do we help data scientists work with data in machine learning. We all know managing data for machine learning is very challenging. For our data scientists to get started with a machine learning project, it usually needs to read data from multiple sources, load it into different machine learning scenarios, and there are so many frameworks that data scientists need to learn to prepare data and training the models. So all this complexity adds up, leads to a few key challenges. The first one is around data access. So other major AI platforms recommend users to copy data into one storage service that they can support. And this leads to massive data duplication and synchronization problem. Also, if on the other hand, if you decide to write your own code to connect to your storage service, you usually ends up hard coding the credentials, the connection strings in your script, which is insecure and fragile. The second challenge is around data delivery. So basically, how do you load your data? And the way users gonna load data into your local laptop or on a remote virtual machine can be really different. And in the past, all our training products and inference products have different interface for data ingestion. And all these frameworks have its own methods for data loading as well. So all these different interface leads to very steep learning curve for data scientists. The last challenge is around data lineage. So basically, after your model is produced, the next problem data scientists needs to solve is to prove how my model performance is actually reproducible. And in the past, users have to manually check the information about how the model was produced, which piece of data was used to produce the model. And so with all these challenges, so what's the solution Azure Machine Learning offering to help you manage your data? We are announcing the general availability of Azure Machine Learning datasets at this conference. It helps make your data available for your machine learning experiments. I will talk through how datasets is the solution to help you tackle all the three challenges one by one. So the first challenge we talked about is around data access, which leads to data duplication and security concern. With Azure Machine Learning datasets, you can read directly from multiple data sources. We support blob, file share, ADS, Gen 1, Gen 2, SQL, PostgreSQL. By creating a dataset, you create a reference point to the data in your storage service. We do not copy your data, so no extra storage cost is incurred when you create the dataset. Second, we help protect your sensitive information by saving users' credentials into your own key vault. So you do not need to hard code any of the connection strings yourself. Lastly, we support role-based access control to meet the security requirement for big organizations. So after gaining access to your data, the next problem data scientists need to solve is, okay, how do I load my data into different machine learning frameworks and different training inference products? Azure Machine Learning dataset is deeply integrated with the rest of Azure Machine Learning service. You can use dataset as the input for all our training and inference products. On top of that, we understand for most of the data scientists, they will probably start model building on their own local laptop and probably with sample data. And once the model looks promising, they will switch to a remote VM with big size data. And with Azure Machine Learning dataset, we make that switch really easy by enabling the capability to mount data from all the storage service we support to any Linux-based computer. So in other words, you will use exactly the same code to mount your data from your data lake, for example, to your local Linux laptop or to a remote VM. Lastly, we embrace open source. So you can just convert Azure Machine Learning dataset into pandas or Spark data frame with one single line of API call. Lastly, dataset helps track how your data is used in machine learning. For each experiment run, you can find the information of input datasets, and you can even register datasets with your model and retrieve the information later in order to reproduce your model or meet some audit requirement. So in summary, Datasets is our solution to help users manage data. Firstly, we support direct access to multiple data sources in a secured fashion. Secondly, we help deliver your data into different training and inference scenarios with built-in support for open source libraries. Third, we automatically check how your data is used in machine learning. So with that, I will move to a live demo that shows most of the capabilities we just talked about. You can download the demo notebook at aka.ms/ignite-dataset. So here is the machine learning studio. This is a centralized place where you can authorize your machine learning experiment, manage assets like datasets, models, service endpoints, and compute. So in this demo, I will use Notebook to authorize two-step machine learning pipelines to help you build an image classification model. So imagine you own an e-commerce business where you have tens of thousands of images that you need to classify into different categories. And that's a great problem that machine learning can help you solve. So I'm using MNIST Fashion, which is a collection of 70,000 images with a label from 10 classes. And I will use those as my training set to build an image classification model with Keras. So to start the experiment, I will first import the packages I will need for the notebook. Then I will load my machine learning workspace, create a machine learning experiment under the name of Keras MNIST Fashion. Usually for machine learning problems, because you need to deal with big size data, and you will need a more powerful compute on the cloud. So here I'm creating Azure Machine Learning Cloud compute, attach it to my workspace. And this is the compute target that I'm going to use for my training later. Here I'm ready to create and register my MNIST Fashion dataset. Here I will first get the blob storage from my workspace, create a dataset pointing to this MNIST Fashion folder in my blob storage. And this two-path method will list down all the files being referenced by this dataset. Again, when creating this dataset, we do not copy your data, so no extra storage cost is incurred when I run this line of cell. Then I will register my Fashion DS with my workspace so that I can use the same datasets in different experiments or as the input for other authoring experience here. Okay, now I'm ready to build a machine learning pipeline. My pipeline is composed of two steps. The first step is the data preparation step, where I will load the images and labels into one big table. With the first column as the label and the rest of columns as the pixel values of my images. And the second step is a training step where I will build a convolutional neural network with Keras. Here is where I set up the compute environment of my virtual machine to install the necessary packages. And then I will configure my first preparation step with the input as fashion dataset, the one I just created and registered. So this line of code basically tells, please mount my fashion DS to the virtual machine. And the output of my prepared step is prepared fashion DS, which is an intermediate dataset that's being output from this data preparation step. If we take a look at prepare.py, so this is the code that will be run on the remote compute, and it basically just converts all the images and labels into one CSV. The second step is the training step, where I will use my prepared fashion DS, which was the output from my previous step, as the input. And if we take a look at the training script here, I'm getting my input dataset from the run object. This will return me the Azure Machine Learning dataset object. And usually for machine learning problems, we will split the dataset into train and test so that I can evaluate my model performance. So I will randomly split the dataset into training and test sets, convert the dataset into pandas data frame. So in the presentation, we talked about how we support open source and make it very easy for users to convert Azure Machine Learning datasets into common data structure, and that's a live example there. After that, I will construct my neural network, log the performance of my model, and save the outputs into a folder. Okay, my pipeline is ready, and now I'm composing the pipeline with the two steps we just configured, the preparation step and the training step, and submit the experiment run. I can monitor the status of my run here by just running this cell. So it's not started yet, so it will take some time to install the necessary package, spin up my compute. So in that case, I will just switch to another the notebook I run just now, where it has all the outputs. So after the run is finished, you can use get matrix to take a look at the metrics being logged for your model performance. So my model, the accuracy of my model is around 92%, which is pretty decent. So I will register the model with my input datasets by calling register model, pass in dataset as the input. So that's an end-to-end notebook experience of how you can build a machine learning pipelines and train with datasets. Now I will do some exploration. So if I go to the dataset tab, it will list down all the datasets I ever registered with my workspace, and here is where you can find the fashion DS we played with and the prepared fashion DS, which was the output of one of my pipeline steps. And one thing to note here is that every time you rerun your pipeline, it will automatically generate a new version of the dataset, and you can toggle here to revert back to a previous version if you want. And then I can go to the experiments tab, where we have the curious eminence fashion experiment we just submit. This lists down all the runs I have submitted under this experiment, and if we click at the latest run, it is already completed, and here you can see the pipeline graph with dataset as the input, which is the fashion DS we used, and the two-step pipeline with preparation step and training step. So we talked about how datasets help track how your data is used in machine learning, and this is a great example where you can find your input dataset, and if you click here, it will redirect you back to the fashion DS dataset page where you have all the details about these datasets. And if you remember, at the end of my notebook, I registered this dataset with a model. So if I go to Model tab, it will list down all the models I ever trained with this dataset. So with that, I will switch back to my slides. So we have a few more sessions about Azure Machine Learning on Thursday and Friday. I would recommend this breakout session at 3:30 tomorrow, where you will learn how to use label dataset to train a computer vision model. And if you want to start trying Azure Machine Learning, here are some useful links for you to get started. With that, I will end my presentation, and we have several booths over there if you have questions, and I will stay around for any questions as well. Thank you.